Welcome to today's exciting lesson on trigonometric integrals, part 1. We'll continue part 2 tomorrow. Now, we're going to be using a few trig identities that you learned in pre-cal last year. One, the Pythagorean, and our double angle identities. Now, notice we're dealing with cosine 2x, not sine of 2x, because anytime you have like sine of 2x, or it's just use substitution, because that's just sine. It's like if I had sine of 2x, that's just 2 sine x cosine x. I can always just use substitution to integrate those. Now, so let's take a look at an example like number 1 here. I want to integrate cosine cubed of, let's say, 5x right here. So if I wanted to integrate this one right here, what I would think is, first, I don't know the integral, so what can I do to kind of manipulate this to make it look a little bit more pleasant? Well, I notice the power. That's a cubic power. I can split that. I can make that an even power. I can go cosine squared of 5x times the cosine of 5x. Don't forget the dx. Now, you may be thinking, Mr. Wernow, why would you ever do something like this? Very simple. Because I can rewrite cosine squared of x as 1 minus sine squared of 5x. And now we might be getting kind of the general idea of what we're going to do next. I am now going to use substitution because the derivative of sine is cosine. So if I let u equal sine of 5x, be careful, not the square, just the sine of 5x, its derivative would be 5 cosine of 5x dx, and I would get dx equals du over 5 cosine 5x. Rewriting it, we would get 1 minus u squared, because that's, remember, I replaced sine with u, times the cosine of 5x, and I get du over 5 cosine 5x. And the cosines cancel out very nicely. And if I bring out the 1/5, I'm left with the antiderivative, 1 minus u squared du. And I know how to integrate this one. We will get 1/5 u minus u cubed over 3. Don't forget your constant of integration, that plus c1. And I'm going to distribute and replace my u's at the same time, and we get 1/5. This becomes sine of 5x minus 1/15, because if I distribute the 1/5, I get 15. 1/15 u cubed. Thank you very much. I do work out. We get sine of 3, sine cubed of 5x plus, and because we are distributing, we should call that c2, and there's our antiderivative. These are kind of fun. You get to manipulate all those little trig identities you learned last year. So here's a hint. Hint number 1. If the power or on sine and cosine is odd or are odd, if they are odd, here's what we're going to do. This is a religious experience. We're going to save one of the factors. See right here? I save the cosine factor and we convert the other. So we're going to save and then convert the other in terms of the other trig function. So the trig identity we use, if the sign is odd, we use the Pythagorean. And because I can rewrite sine squared of x as 1 minus cosine squared of x, I can write cosine squared of x as 1 minus sine squared of x. Very easy to do. So that's our very first hint. Now, so here we have an example. Oh no, I have cosine cubed and sine squared. One's odd, one's even. It doesn't matter about the even one. It's the odd one that we care about that makes it tricky. There's my odd power. So what I'm going to do is I'm going to take out one of those powers. Okay? And that's going to leave me with cosine squared of x times the cosine of x times the sine squared of x dx. The one with the just by itself, that's the one I'm going to save for later. We're going to save it like dessert. Like when you're eating dinner, you save your vegetables for last. Just kidding, I always eat mine first, get the pain out of the way. So there's one I'm going to save. The other cosine with the square power, that one I'm going to convert into terms of sine. So when I do this, I'm going to get 1 minus sine squared of x times the cosine of x, I'm saving it, times sine squared of x dx. And now we're going to use our u substitution here. So, remember the one I converted? That's where I get my u from. U is the sine of x. Du is the cosine of x dx. Hopefully you see it. What's going to cancel? The cosines. So if I were to rewrite this, we would get 1 minus u squared times the cosine of x times, not sine squared, we replaced it with u, and I get du over cosine of x. Now, remember that cosine we saved? You know, mathematics is harsh. It's violent. Here we saved this cosine just to eliminate it later. We killed it. And what I'm left with, if I can expand this, I'm going to get u squared minus u to the fourth du. And I can integrate this. I get u cubed, thank you, over 3 minus u to the fifth over 5 plus your constant of integration. And now I just replace my u. U is sine, so I get sine cubed of x over 3 minus sine to the fifth of x over 5 plus c1. And there's our terrible. Focus. And there's our antiderivative right there. Sorry about that. So let's take a look at a couple more examples. Because what happens if the powers are even? That's what we're going to talk about next. If the powers are even. Now notice, a lot more space down here. These require a little bit more work. So if the powers are even and positive, we use the double angles. These are for the if the power is even. And here's what we're going to do. I know the integral of cosine of 2x. It's just negative 1/2 sine of 2x. Okay, that we get that by u substitution. The problem is I don't know the antiderivative of sine squared or cosine squared. But the double angle allows me to replace that. So I can go sine squared of x equals, and this becomes, if I solve for this, 1 minus, excuse me, I want to make sure I get this right here. Algebra is always kind of tricky. Yep, 1 minus cosine 2x over 2. Sorry for that brief pause. Had to make sure I get the signs right. Okay, don't want to mess you guys up too much. Had to do some arithmetic in my head. And over here, same thing. I know the antiderivative of cosine of 2x, but not cosine of squared x. But I can solve for the cosine squared of x, and that's going to give me 1 plus cosine of 2x over 2. So when I come down to here for a problem like number 3, and I want to integrate this, I notice that they are both have a power of 2. The power is even. So since they're both even, I got to replace them both. So I'm going to rewrite this as 1 minus cosine of 2x over 2, 1 plus cosine of 2x over 2 dx. Now, if you're smart, factor out the 1/4, because each of those have a half. 1/4, and I'm left with 1 minus cosine 2x, 1 plus cosine of 2x dx. Expand, that's a difference of squares. Remember this? A plus b, a minus b. We get a squared minus b squared. And rewriting it, 1/4. This becomes just 1 minus cosine squared of... Oh no, I messed up. Remember this right here was 3x? That makes each of these a 6. I know some of you guys have probably already caught on to that, but I'm going to go and fix that right now. Those all should be a 6x. Oh, that's terrible. So sorry about that. Those all should be a 6x. So then this becomes 1 minus cosine squared of 6x dx. So remember, I messed up because the rule says it's twice x, and it was 3x. Those should be 6x's, not 3x's like I had them. So please be careful of that. Very easy to make that mistake, as you can tell. Okay, so I did fix that for you. So please make sure you fix those. Now, but you may notice, though, again, I have another even power. So what does that mean we have to do? We have to do it again. 1/4, and we get 1 minus, and I can replace this cosine squared of 6x, here's my rule, with 1 plus the cosine. Again, I don't want to make the same mistake again. That was a 2x, So I got to make that 6 a 12x this time over 2 dx. Now this I can expand. I get 1 minus, this becomes 1/2 minus 1/2 the cosine of 12x dx. Now when I integrate this, now I can integrate. I'm going to get 1/4. When I integrate this, I'm going to combine those two. 1 minus 1/2 is just 1/2. That's going to give me 1/2 x. Minus, now over here, I got this 1/2, but when I take the antiderivative cosine, it is sine of 12x plus my constant. But I have to divide by 1/12. I get this from my u substitution. So I divide by the 1/12. So when I distribute my final answer, I'm going to get 1/8 x minus 24 times 4, 1 over 96 sine of 12x, and again we should put that plus c2. Now some of you guys might have recognized this one, 1 minus cosine squared of 6x. You can write this as just sine squared of 6x if you want to. You don't have to do that if you don't want to, though. Okay, I like doing it this way. You'll get the same answer either way. So let's take a look here at number 4. Now number 4 is a little bit trickier. Here we got this 4 right here. All that means we have to do this twice. And we're going to go to part 2 for number 4 because I don't want to make this too long of a video before YouTube says you can't use this. So I'll see you in part 2.